Hello and welcome to Arduino. In this video, I will show how to interface liquid crystal display to Arduino. So let us go to Walkthrough Simulator. Click on Arduino Uno. Now select liquid LCD 16 by 2 with this liquid crystal display with 16 columns and 2 rows. So the LCD consists of the pins called VSS, which is a ground pin, VDD, plus 5 volt supply, V0, it is used to adjust contrast of the display, RS, resistor select. To select data register, this pin should be kept high, and if to select command register, it should be set to low, and then read and write. This pin always LCD is used in write mode, hence RW must be connected to ground. E enable pin to send data to pins, and D0 to D7 or 8 data pins. Among this, D0 to D3 are optional. So we can connect D4 to D7 to Arduino, and hence LCD can be operated in 4-bit mode. And A is anode pin of backlight of display, and K is cathode pin of backlight display. So now let us do the connections. First is VSS should be connected to ground. So let us connect VSS to the ground. V0 also should be connected to ground. RW must be connected to ground because we are not we are using LCD in write mode, so it should be connected to ground. And then connect VDD to plus 5 volts power supply. Now, we have to connect the pins RS because we are using as a data register, and then E enable pin, and D4, D5, D6 and D7. So RS to 10, enable to 9, D4 to 8, D5 to 7, D6 to 6, D7 to 5. We'll change the color of the Y so that it will be very easy to understand. So we'll go to diagram JSON, and for ground we use black. All ground connections will go with black color. And then supply with red color. RS with the pink, and enable with the violet. And the 4 data pins will leave it with the green color. So this is the circuit diagram. Now it is very easy to identify the connections. So this is the connection. So these are all. This is how we have to connect LCD to Arduino. Now coming to the programming session. So here we have to include a header file, that is hash include liquid crystal .h header file, choose that. And then initialize. So we'll create an object, liquid crystal. Liquid crystal, I'll take LCD. And this, so this must have, this function must have 6 attributes. That is the pins that we have used for the connection other than the power supply and the ground. So we have used 10 for RS, 9 for enable, and 8, 7, 6, and 5 for data. So 6 attributes. The first 2 are one for the register. First one is a register select, next enable, and the next 4 pins are data pins. So this is the initialization of LCD with the connections. Now go to the setup part. So begin LCD dot, we use a function called begin. The size of LCD is 16 by 2, 16 columns and 2 rows. So we have to set LCD size, that is 6 columns and 2 rows. Now go to the loop. Now we can print any message onto LCD. So for that, we can set the cursor. So it has 2 rows. So this is the 0th row and this is the first row. And 16 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So 2 rows and 16 columns. So I just want to print the message on starting from the column 0 in the first row. So I'll set, it is there is a function called LCD dot set cursor so at the 0th column, 0th row, that is the first row, 0th column, and then print any message. There is another instruction called print instruction, LCD dot print. Whatever message you want to print, you can print in the brackets. Welcome. Semicolon. So let us start the simulation. So because we have set the cursor at 0th row and 0th column, so it has started from the beginning. I can change the cursor position to 6th column, 0th row. Again, you can start the simulation. So this is 6th row. I can also write, use the other row, and for that, we'll again use this and print some other message. So this is, we'll start with the 6th column, but next row, that is called first row. So this is 0th row, this is first row. And then I'll print welcome to Arduino. So let's start the simulation. So welcome to Arduino. So this is how we can interface LCD with Arduino. We can also, there are number of functions out there where we can scroll the messages to left and to the right. So I'll show one more example. I'll write another program for scrolling of the message. So I'll stop the simulation. Now we'll write. So again, set the cursor, LCD dot set cursor at 0, 0. Semicolon. Now use print for printing the message. For that, first we'll take a string. A string M is equal to hi, semicolon, LCD dot print the message. Here we are only printing the message. So here I have initialized the message. Instead of writing in the print instruction, I have taken a variable, a string, and then I have taken the message and assigned it to a string M, and then I am using M here for the printing. Now I want the message to scroll to the left. For that, I'll write a loop for int I is equal to 0, semicolon, I. So what is the length? How many characters are there? That we can measure by using a function called m.length. So from 0 to length of the string. There is a function called length. So m is my string. So m.length, semicolon, increment, character by character. So I'll take the loop. So LCD, now we have to scroll, right? LCD dot scroll display left. There is also another function called scroll display right. And give some delay. 500 milliseconds. Now, in this program, what I did is I have taken a string and then I want the string to scroll to left. So for that, I have used a for loop. So for I is equal to 0, I length of the I less than the length of the string, I plus plus. So it goes from 0, 1, 2. The length of the string is 3. So it goes from 0, 1 to 1. And I have used a function lcd.scroll display left to display the message to the left, and I gave a delay of 500 milliseconds. So let us stimulate. We can give the time delay of, so this is 500. We can give less time delay, 120, and then so we can control the speed, the scrolling speed with a delay. So it is scrolling to the left. If I want to scroll it to the right, I can use, instead of left, replace with right. Now, again start the simulation. It will scroll to the right. So this is how we can interface LCD with Arduino. So this is the header file which is required for the operation. And then for initialization of LCD with the connections, we have to use liquid crystal LCD, which takes the function liquid crystal LCD with 6 attributes. That is the connections or pins, and then set the LCD size. So LCD dot begin 16 by 2. Next, the set cursor, the position of the cursor on LCD, because it is 16 by 2, 16 columns and 2 rows. The first one is the column attribute, and the second one is the row. So you can choose a column and the row, and then whatever message you want to print, you can directly use lcd.print the message. You can write inside this function, or you can take a variable, a string variable, and then assign to it and use that string variable. Because I want to scroll the message, I have used a for loop. Otherwise, it's enough if you use lcd.print message. So it displays the message on to the LCD. If you wanted to scroll to the left or to the right, we have to use this function. For this, we need to use the loop, and loop for int is I is equal to 0 to m.length. That is message to the length of the message. It will increment one by one, step by step. Then LCD dot store display write function delay for a 120 milliseconds. I hope you understood. Thank you.